Formula we're looking at today is the one that tells us the sum of the interior angles of a polygon. And this little diagram that we have here is a neat one. I'm going to make a link of it show up on our Moodle page. I want you guys to all go there and mess around with it a bit. And the thing that's neat about it is it kind of shows you intuitively why, once you know the number of sides, you're going to always get a specific number of degrees in the angles for that shape. And this is true even if you're not dealing with a regular polygon. Here I'm going to make this guy not regular. Okay, so this is a hexagon. It's got 6 sides, you see here. I can control the number of sides by clicking less or more here, right? And even if it's not regular, you see here that when I'm pulling these around here and I'm changing the number of degrees in some of these vertices, right now you see this 95 here, that's just the number of degrees in this corner. If I move this corner so now it's got a smaller angle here, this number is going down here, but these angles are getting bigger to compensate for it, right? So no matter what I do with this angle here, the total that they all add up to is staying 720. Because if it's a hexagon, if it's a 6-sided figure, it's always going to end up being 720. That happens even if I'm messing around with this other side here. And this shape, you might say, okay, well, I recognize that it's not regular, but this is definitely a convex shape. Do things change if I have a concave shape? Well, let's see. Let's turn this into a concave hexagon by bending one of these vertices inward. Even if I do that, even if I make this a concave polygon, I'm still getting a total of 720 degrees because it's a hexagon, right? And once you know the number of sides, this number is always the same for that number of sides, right? If it's a pentagon, that means 5 sides, it's always going to add up to 540, no matter if you make this angle a lot bigger, if you make it a concave pentagon like I have here, if I make it convex like it was here, if I make it a regular pentagon, no matter how I mess with it, I'm still ending up with 540 degrees here. And you guys have already seen videos that tell you what that number is going to be for each shape, right? The smallest number of sides you can have for a polygon is 3, and that's a triangle. You know this from last year. If you've got a triangle, you're always going to have a total of 180 degrees when you add up the number of degrees in the vertices, right? It's always going to be 180. And then every time you add a new side to your polygon, to the total number of sides, like if I go from 3 sides to 4 sides, this total number of degrees is going to jump by 180. And you guys already know why that is. It's because if you take your new shape and you chop it up into triangles like this here by drawing a diagonal from one vertex to another, that will give me 2 triangles. I can't get more than 2 by drawing diagonals. I'll get exactly 2, which means 2 times 180 to get me 360. Okay, so I'm going to put this link up. I'm going to ask you to go there and amuse yourselves with it to whatever extent you want. You know, twirl things around, woo, make it bigger, smaller, whatever you want to do. But really the goal is just to get used to the idea that no matter what you do, you're always going to end up with the same total number of degrees for whatever number of sides you're dealing with. If it's 8 sides, that's 1080. If I bump that to 9 sides, this number is going to go up by 180 more because it's one more triangle I can fit in it, right? So that's your basic rule about interior angles. Now, the next thing we're going to look at is applying that rule as a formula that helps us solve problems.